Okay, so welcome to your first flipped video. Yay! We're going to be talking about scientific notation. I'm going to give you two questions, or two statements, and I want to see if you can fill it in. A quarter has about, okay, and I know we're writing these on your notes, and we're not doing fill in the blank like last year, but that's because you're 8th graders, and you can do it now. So we're going to give you responsibility. Sometimes you'll get some notes, though, and not always write it. So how many atoms do you think a quarter has? Alright, and then one atom is about centimeters, blank centimeters in diameter. Now, I'm sure this video is lagging just like the 7th grade one did, and if that's true, then please just pause it and rewind it. So we're going to come back to that later. But we're talking about scientific notation because it's at the top of our page. So scientific, we're going to write a definition. Scientific notation is a universal way, universal means everybody does it, way developed by scientists as a shortcut for writing very large and vice versa, very small numbers. Alright, so these are going to be either very big or a very small number because we know atoms are small. So I'm going to write it out for you. It's 97, comma, then write a 700, and then you're going to do 6 sets of zeros. 1, 2, 3, 4, 5. That is a huge number. And I'm going to be honest with you, I don't even know how to say it. Alright, and then one atom is about, this is going to be a small number, right, because atoms are tiny. You're going to write 7 zeros, 1, 2, 3, 4, 5, 6, 7, and then a 3. It's an itty bitty number, and that's really time consuming. So scientific notation is great because it's going to teach you how to write that easier. Alright, there's two ways to look at it. You have something called standard notation versus scientific notation. Now the great thing is you can go from standard notation to scientific notation and vice versa, and we're going to show you how. So this huge number that we wrote up here, we're going to write that in standard notation. That is in standard notation actually, so we're just going to recopy it. Standard because it's long, and I'm going to show you how we're going to say that. So you write 97, then you write 700, then we had 6 sets of zeros. Okay, so this is the long version, right? So when you're texting your friends, you're not going to say laugh out loud, right? Just like if you're writing this, you're not going to write it. You're going to want to write it a shorter way. So we're going to call the standard notation laugh out loud because you're actually writing out the full thing. We're going to write scientific notation. Remember, that's the short way to write things. It's going to look like this. Now, I know you don't know what that means, but isn't that so much easier to look at than this huge jumbled mess? So we're going to call this, since we said it's a short version, short way to say laugh out loud is LOL. So that's what we're going to call scientific notation. Okay, you have a formula. Your formula for scientific notation you're going to have a number, just like we have a number right here, the 9 77/100. You're going to have some number. Okay, you're going to multiply it by 10. And you're going to have an exponent. And your exponent can be any number. Okay? You don't have to have 2 decimal places, but you'll always at least have 1. So we'll put that there too. Now, this digit right here is so important. It's so important that you know that this number must be only 1 digit, and it has to be between 1 and 9 and 99/100. So for example, we could have 1 whole, we could have 1 2/10, or we could have 9 97/100. Okay? This is called your base. Remember when we're talking about exponents, the big number is called your base. So your base will always be 10. It will always, you're always going to multiply it by 10. Your exponents, remember, those are your little numbers next to your base. Your exponents, guess what? They can be positive, or what do you think? Or they can be negative. Okay? I know you've probably seen this in science, but we're going to do it in math. Alright, so let's look at an example. We're going to take this example that we've been using. The quarter has about however many atoms. So you're going to write it again. Kind of spread it out this time. Alright, so we know your first step is to figure out what this number is going to be. And I know that this has to be between 1 and 9. So I look at my number. Where is my number where I can have 1 and 9? Well, if I put my decimal here, it's not going to be between 1 and 9. That's 97. I need this to be between 1 and 9. If I put it here, it's 977. That's not going to work. So we need to put it right between the 9 and the 7. I'm going to use a different color. Your decimal needs to go there. So you can go ahead and put 9 with your decimal. And then fill out your whole digits. You're never going to write your zeros. So just fill out the rest of your digits. So 7, 7. Okay, if we're looking at our formula, we know we're going to multiply. So I can write multiply. Well, I know my base will always be 10. So I can go ahead and write 10. Now I need to know what my exponent's going to be. Your exponent of blank is the number of places you move. What do you think? Move your decimal. Alright, so let's figure out how many times we move our decimal. Well, Ms. Hitchcock, where are we trying to get our decimal to? We want to get it to the end of the number. So we have to go figure out how many spaces are between where we started our decimal and where we're going to end our decimal. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we moved our exponent of, or we moved our decimal places 22 places, so that's going to be what our exponent is. Our exponent of 22 is the number of places you move the decimal. Okay, if you're lost, it's math. You might get lost, but just keep with me and it'll eventually make sense. If you need to pause it, pause that so you can finish writing your notes. Alright, we have another example. We have kind of the opposite example though. Remember on your last page you had the big number and then we had the tiny little decimal when we were talking about centimeters. We had 1, 2, 3, 4, 5, 6, 7. We had 1, 2, 3, 4, 5, 6, 7 zeros and a 3. Alright, well you know that your first number has to be between 1 and 9. So where can I put my new decimal so it's going to be between 1 and 9? If you put it here, that reads like it's like 30 cents. That reads 3/10. That's not going to work. So you have to put it on the outside of your number because that will read like $3 or 3 wholes. So you know your first number is going to be 3, but we always want to have a decimal, so we're going to do 3.0. Right? You're always going to multiply it by a base of 10, and now we have to figure out your exponent. Okay, so we have to figure out how many decimal places are from here to here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but do you realize we went a different way this time? Okay, so we're looking at this. We know we moved our decimal places 8 places, so our exponent's going to be 8. But if you notice, this is a smaller number than we were just talking about. The other number was huge, so it's probably not going to be a positive 8. It's going to be a negative 8, and I know that makes no sense, but please hang on with me for 2 more seconds. I'm going to explain why. All right, down below here, we're going to do 2 little hints. If you have a positive exponent, like our first example, that means your number, your whole number, this is going to, or like this number, is going to be larger, greater than 1, so larger. Move your decimal to the right. Okay, so if you looked on the first example, we had 97, blah, 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 blah. Remember, we moved our decimal this way. Okay, moved it to the right. Now, when you have a negative exponent, means your original number, your number is less than 1 or smaller than 1. You're going to move your decimal to the left. So we started with our decimal here, and I counted the wrong way, but you started with your decimal here, and you're going to move to your left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's why we have a negative 8, because our original number right here is smaller than 1. Alright, so let's do some examples. We have our laugh out loud. What do we call our laugh out loud? We call it our standard form. Then we have our LOL, and that's called our scientific notation. Alright, so hey, so did you just pick and choose, like you did some in standard form to scientific and then some in scientific to standard form? Okay. Alright, so let's look at 48,000. Alright, we want to get our standard form into scientific notation. Pause it and see if you can do it on your own. Okay, Okay, so we know that we need our first number in our formula. Our first number has to be between 1 and what? It has to be between 1 and 9. So we need, if we put our decimal here, it's going to be 48. That's too big. So we want to probably put our decimal right here because 4.8 or 4 8/10 is between 1 whole and 9 wholes. So 4 8/10, we know we're always going to multiply by a base of 10. Now, is this number, are we going to have a positive exponent or a negative exponent? You know that because is your number larger than 1 or is it smaller than 1? Is 48,000 larger than 1 or smaller than 1? I hope you said larger. So we're going to put our decimal here and we're going to figure out how many decimal places we need to move to get to the end. We know we're moving to the right, so we go 1, 2, 3, 4. Move to the right, 4 spaces, it's a positive exponent. Alright, let's do 320, try that on your own. Alright, you should have saw that your whole number would have been 3.2 or 3 2/10. So your decimal would have been here, you would have multiplied it by a base of 10, and your exponent's going to be how many places we move our decimal to the end of the number. So we move it 1, 2 places, so your exponent will be a 2. Alrighty, let's do, oops, I kind of just gave you the answer. Let's do 10. It's going to be between, I need my number between 1 and 9. Put it here, that's between 10, that's too big, so I need to put it here, and I have it right at 1. How many decimal places do we move to get to the end of the number? We just move it 1 decimal place, so your exponent's 1. What if we flip-flopped it? What if I gave you this side? What are we going to do? And then I trick you up and I give you a negative exponent. Alright, so what you're going to do is you're going to rewrite this number over here. 5 81/100. Okay? I see that my exponent's negative, so I know my number's going to be smaller than 1. If you need help figuring out which direction you're going to move your decimal, think of your exponent as a wall, okay? And you have this negative sign. Well, if you can't go into the wall, so we don't want to draw our arrow that way. We want to draw a fake arrow that way, so we know our decimal place is going to move this way because it can't go into the wall. So, I would need to go to the left 4 places. 1, 2, 3, 4. Here's my new decimal place, and you fill in the loops with the zeros. Okay, another one. We gave you 9 times 10 to the negative second. Try that. You should have rewritten your 9 wholes. We know that our decimal place is going to move to the left because if we move it to the right, it's going to run into our wall exponent. So it's going to move to the left. How many places? 2 places. 1, 2. So your answer is 9/100. Alright? Just a few more, y'all. I don't want to write that. 3 7/10 times 10 to the 10th. Alright, that's going to be big. Now, if you know that negative exponents go to the left, positive exponents are going to go to the right. So you want to rewrite your number, 3 7/10. I need to move to the right how many places? You should have saw you need to move right 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill in your loops with zeros. $37 billion. Alright, 2 more I want you to do on your own, and then pause the video and come back and check it with me. And then 208,000. Alright, if you're rewriting your LOL, your scientific notation number, you would have rewritten it over here. 76253. Seeing that your number is positive, so we're going to move to the right 5 places because positive numbers go to the right. 1, 2, 3, 4, 5. And we just have a simple 176,253. Okay, and last one, you should have saw that your whole number is not going to be 20 and 8/10. It should be between 2 and 8/100. So we write our whole number. You multiply it by a base of 10. And is this a number bigger than 1 or smaller than 1? You should have said it's bigger than 1. So you know it's going to be a positive exponent. So we need to figure out if that's where our decimal place starts. We need to go 1, 2, 3, 4, 5 places to the right, and if we're moving to the right, it's going to be positive. Alright, y'all, you have a quiz to take. It's going to be above this video. Do not forget to take the quiz. That's the only way that you can get credit for watching this video. We don't care if you just have your notes. You have to take the quiz and take it seriously. It will be for a grade. Have a great night.